Okay, so now let's start with chapter 4, which is called NumPy. NumPy is a library that's available in Python. So NumPy is short for numerical Python. Okay. So what we have discussed so far, those concepts are base Python. Now, if you want to set up large data sets and then you want to do operations on the data, then Python becomes really cumbersome. You have to write all this code, for loops and while loops and if and all that kind of stuff. So to make those operations easier, one, and then to write the code in a way that is very efficient. Okay. Some of these libraries, people have developed these libraries and they are available. And there are two that are important for data analytics. NumPy is one, okay, and NumPy sits on top of Python. So it's able to use all the Python base capabilities and then it soups it up. Then on top of NumPy sits what is called pandas. So but before we get to pandas, we have to look at NumPy. Okay, so NumPy, as I said, is numerical Python. So here are some of the concepts here. ND array is what it creates. Okay, when you use NumPy, you create arrays of data. And it is called ND array because it is n-dimensional array. That's what ND array stands for. N-dimensional array. Multi-dimensional array providing fast array-oriented arithmetic operation. So you can check, so this is at least 10 times faster than the base Python or more. And your textbook discusses that, the speed of operations. Fast mathematical computations on entire arrays without having to write loops. So if you have a big list of numbers, you don't have to write, you have one list of numbers, another list of numbers. You say A plus B, then NumPy will match pairs of numbers and add them up and give you the result without you having to write, like iterate through one list, iterate through another, and then adding up individual items. No, you don't have to do any of that. The mathematical functions of the entire array happens without you having to write loops. Tools for reading and writing array data. And then there are some random number generators. Then there are some mathematical packages that are available. And then there is an API for C, which you don't have to worry. Okay, so here is the properties. The NumPy array is multi-dimensional array object. Okay, ND array is n-dimensional array. And here are some important features of NumPy array. NumPy array is homogeneous data. All elements are of the same type. So this is important. Okay, so if one element is integer, then all the elements are integer. If one element is floating point, all elements are floating point, and so on. Okay, and NumPy, in most cases, it will automatically coerce the data type, okay, so that all the elements can coexist. So if you have some numbers and then a string, then for the string to exist in this array, all the other numbers will be converted into strings. Okay? Now, there are three properties of ND array. Shape. It gives you a tuple indicating the size of each dimension. So if you have a one-dimensional array, it will just give you 1. Two-dimensional array, it will give you 2 numbers. So three-dimensional number, it will give you 3 numbers. Okay, size of each dimension. And then the property D type, that will give you the type of the elements in the array. Okay? And then ndim tells you how many dimensions there are in the array. Okay, so let's look at some examples. Okay. Now, for us to be able to use the NumPy feature, we have to set it up, or we have to invoke it, so that you will be able to access the NumPy functionality. And that's done by this import NumPy. So this will work. So if you run this, from this point onwards, all the NumPy features will be available to you, but you have to prefix those features with NumPy. You should say NumPy dot, and then you specify what feature you want to use. Okay. Now, you can give a nickname to this NumPy, so it becomes easier and less verbose when you write code. Right? So you can give, and you can give any nickname you want, but the convention is NP. So I would expect you to follow this convention. So you start with import NumPy with the nickname NP. And from this point onwards, you type NP dot, and then the NumPy feature that you want to use, and you'll have it. So let's run this first. Okay. Now if you see, if you type NPy dot and then press the tab key, you see all the functionality available for NP will show up. Okay. But right now, we're not going to go into each and every one of them. So let's create. Okay, so let's start with a list of numbers. Right? So this is a list, L1. It's a list of numbers. That's just base Python. Now if I say NP_ARR1 is equal to NP see there is NP array. Okay. Then if I give it L1, okay, and then if I type NP_ARR1, that will give you an array. So I should have put this here. So list to NP array. So you have an array, and then it gives you the list. Okay. Now we can see what it is, like NP_ARR1. Okay. So if I say shape, right? So it will give me what the shape of it is. So it says 5. And then a comma, nothing else. So this means it is a one-dimensional array and it has 5 elements in it. Okay. Now I can say NP ARR1 and say D type. Okay, so it tells me that the elements are of type integer 32, so 32-bit integer. Okay. Then I can say NP ARR1, shape, we already did shape, N dim. How many dimensions there are? It has one dimension because it is a one-dimensional array. So these are the 3 properties that are useful for us to check what's in it. All right, let's create some more arrays, and here we're going to be creating data, random data, so we can use those as examples to understand many of the NumPy features. So what we will be using is NP, NumPy has a module called random. Okay, so we'll use the np.random module to create quickly random data. Okay. Now, you see, random module has lots of functionality in it. Okay, so we're going to use rand int first. We'll be using rand n and rand int. These are the 2 that we will use very often. Rand int generates random integers. Rand n generates random standard normal values, normal distribution. Okay. So rand int. Now, how do you set it up? If you want to be sure how to set this up, you can put a question mark by the side, and then it will tell you how to do it. I mean, what data to give. So low, that's the lower end. High is the higher end. And size is how many you want. And then you can specify the data type also, what kind of data you want. So let's say that we want 0 through 9, and we want 24 of them. Okay. And we want to put that in D1. Okay. So now you see that it generated 24 numbers between 0 and 9. Okay. And it is an array, and it is type integer. Okay. Now we can reshape. Okay, you can take the D1 and then you can reshape it. Okay, again, if you look for what's in reshape, it tells you some information. It doesn't give you a whole lot, does it? Okay, so we can say that take those 24 numbers, right, and then reshape it in this fashion. Okay. now if you look at D2, then you see the shape now is 2, 3, 4. There are 3 dimensions to this ND array. The first dimension has 2 elements. The second dimension has 3 elements. Okay, on the the third dimension has 4 elements. So let's look at what that looks like. Okay. So the first dimension, there are 2 matrices. Okay, the second dimension is when you go inside the element from the first dimension. Okay, so you go inside the first element. There are 2 elements in the first dimension. You go into the first element, then you see there are 3 elements inside it. Okay, that's 1, 2, and 3. Okay, and then of these 3 elements in the second dimension, if you go into that, into one of them, you see there are 4 elements. That's the third dimension. Okay, so we can do, if you do NDIM, it will tell you there are 3 dimensions to this array. And then of course if you do D type, it will tell you that it is integer 32. It's very important to understand how the dimensions, the shape works. Okay, first dimension, second dimension, the third dimension.